Next topic that we will be looking at is the LAN protocols. So what different LAN protocols are there? We will be looking at that. So this LAN protocol, we are going to define it into two different types. It will be like for wired LAN and wireless LAN. The first part that we will be looking at is the wired LAN. So this wired LAN is also called as the Ethernet. So in case of Ethernet, what different protocols are there and how it basically works, we will be looking at that. So basically, we will be looking at different protocols associated with the Ethernet. And after that, we will be looking at the wireless LAN. That is basically the Wi-Fi. Okay. So there are different standards given by IEEE. Okay. So this IEEE is a society that is basically for uh, this is an institute of electrical and electronics engineering engineers basically. So this is a society that is having different engineers related to different backgrounds, and they basically set some standards. So that standards should be followed throughout the world. So for different works or for different uh, working of a particular system, they basically provide some standards and some protocols. Okay, so the standards and protocols are set up rules on which a particular system should be working. Okay, so here in 1985, Computer Society of the IEEE. So IEEE is a group. In that there is a computer society. They have started the project called Project 802. So they have started the project 802. This is to set standards to enable intercommunication among equipment from a variety of manufacturers. So like different manufacturers are there because manufacturers can be different, but they should be following a similar standard, similar rules. So that's why they started a project 802. Under this project, they will be basically going to have different protocols, different set of rules for intercommunication between different devices of different manufacturers. So in project 802, here is a way to specifying functions of physical layer and the data link layer of major LAN protocols. So in 802, so in project 802, basically it defines different protocols related to uh, LAN protocols. Okay, so this LAN protocol basically works in physical with the help of physical layer as well as the data link layer. So physical layer and data link layer are the two important layers of the TCP/IP model, network model. In that, this LAN protocol basically works. Okay, so for that, for physical and data link layer, there are different 802 protocols were implemented. Okay, so we will be discussing one by one. So what different types of 802 protocols are there? IEEE, these protocols are called like basically the IEEE 802 protocols. Okay, so we'll be looking at that one by one. So here some IEEE standards for LAN is given. So based on like different layers, so it basically constitute of the physical layer and the data link layer. So into the physical layer, this LAN. So basic LAN is basically called the Ethernet. So Ethernet is the basic LAN. So before going for that, in previous classes we have gone through like uh, data link control we have seen and error control we have seen. Okay, so one data link uh, in that data link basically it was constituting flow control and error control, and then there was a media access control. Okay, so this media access control and data link control. So in data link control, basically it was like flow control or error control. We have already gone through. So and this media access control and data link control. These are the part of data link layer. So this is how it has divided. So under this media access control, so this media stands for the communication media or the cables basically. Okay, cables that we are going to use for making the connections. So these cables, like how these cables are going to be controlled, or what different set of standards are there for controlling these media cables. So under that, they are having different types of LAN basically. So here are different types of LAN, or basically which is called like different types of media access control techniques, or the standards or protocols basically. So one is like the Ethernet. So Ethernet media access control. Another one is called like token ring, then token bus, and there are many more also. So like that we will be looking at later on. So but under the wired LAN, we will be going through the Ethernet MAC, then token ring MAC, then the token bus MAC. Okay, so we will see these one by one. So what other names are there for these? So in basic, in our syllabus, basically it is given like the basic Ethernet. So this first part is basic Ethernet. It is given by like 802.3. So it is IEEE 802.3 protocol. So that is the basic Ethernet. Okay. So next one is 802.4. So 802.4, it is called the token bus. So IEEE 802.4 protocol is also called like the token bus MAC protocols. Then token ring is called like 802.5. So these are the different standards given for like basic Ethernet is given by 802.3. Then token ring protocol, it is also known as like 802.5. Then token bus is 802.4. So we will be looking at these three protocols and what is its frame format. We will be look at that also. So one thing from here we can say like these protocols are part of the data link layer. Okay, so data link layer means here we will be dealing with the frames. We will be dealing with the frames. These are the basics about the IEEE standards that are used for LAN basically. So we will be starting with the 802.3, then 802.4, and then 5 that we will be looking at. So these, so here for Ethernet, that is the part of data link layer. So Ethernet MAC, that is Ethernet media access control. So for that there is some portion or some role of physical layer is also there. So that's why there are some protocols defined, that is Ethernet physical layer. So here for supporting the Ethernet in data link layer, some portion of the physical layer is used. So that is basically called like Ethernet physical layer. So similarly to token ring, so to token ring physical layer will be there. Token bus, so token bus physical layer likewise. And these are like a transmission medium that will be connected with the physical layer basically, that we already know. So here frames are given. So that SDLC frame that were part of like data link layer, that it basically, its basic idea of SDLC frames are like it will be having an address and control bits, then some data from the upper layer. Okay, so some data will be there, and then FCS will be there, some codes basically that will be for indicating some portion of the frame. So similar, it is similar to SDLC frame. It is given like the LLC and MAC frames, that is the logical link control LLC. So this portion that we basically divided is like MAC and LLC. So logical link control and media access control. So in the previous that we have seen is that is basically called like data link control and then media access. So that's logical link control can also be considered like data link control. Okay, so it is the similar thing. So here for both the cases, there will be a separate frames. Okay, so how these frames will be given is given by this only. Okay, so in combined data link layer, SDLC is considered as one of the frame that will be constituting both the part. Okay, but in once we are going to consider it as two different parts, SC and MAC, the portions are divided into two different frames. That will be one that will be for LLC and another will be for MAC frame. Okay, so this is how it is basically represented. So no need to go deep into that. We will be basically going with the LAN protocols. Okay, so it's standard. What is different standard LAN protocols are there? We will be looking at that. So standard Ethernet. So this standard Ethernet is basically given by like 802.3. So IEEE 802.3 protocols. Okay, so here the original Ethernet was created in 1976. So the first Ethernet, that is the basic or standard Ethernet, was basically created at uh, Xerox Palo Alto Research Center, that is PARC. So this is a company, is research center. At this research center, it was created in 1976. So since then, it has gone through 4 generations. So different modifications to the Ethernet have been done. So these different modifications from the standard Ethernet have been done. So it is like 802.3, then likewise different versions are there. So some different versions. So these different versions are called like Ethernet evolutions. So these different evolutions are like, first is the Ethernet, standard Ethernet, that is 802.3, then fast Ethernet, then gigabit Ethernet and 10 gigabit Ethernet. So likewise different evolutions are there based on the speed. So standard Ethernet is having only 10 Mbps speed. Then fast Ethernet is having 100 Mbps. Gigabit Ethernet is having a speed of 1 Gbps. Then 10 gigabit Ethernet is having 10 Gbps as the speed. So in LAN also or Ethernet, basically there are different generations or different evolutions to that, and based on the different higher technologies, they are having higher data transfer rate basically. So we will be going with the basic one, that is the basic Ethernet. Okay, so here the basic Ethernet, that is the 802.3. So here IEEE 802.3 standard specifies the CSMA CD. So carrier sense multiple access with collision detection, we have already gone through. So this Ethernet, that is IEEE 802.3, uses CSMA CD. Okay, so one we have gone through CSMA CA. So once we were going with CSMA CA, this is used basically in case of Wi-Fi, and in wired LAN CSMA CD is used. Okay, so here 802.3 standard will be using basically the CSMA CD method. CSMA CD is the most commonly employed access method for LANs using a bus or tree topology. So here in LANs, they will be using CSMA CD, and that different stations will be configured either in bus topology or in true topology, tree topology basically. So with the help of CSMA CD technology method, they will be using bus or tree topology. It is the media access control method used by Ethernet. So Ethernet in the sense, yes, okay. So Ethernet 802.3. So most widely type used at present is this one with a huge installed base and considerable operational experience. Protocol is very simple and stations can be added without making the network down. So once we want to add a new station, because it is having a bus topology, so we already know like in bus topology it is like this. So there will be a common cable. To that there will be different stations connected. If we want to add another station, we can directly add it. Okay, so there is no not that complex, and it will not be going to stop the working of the previously connected devices. So it is stations can be added without making the network down. The delay at low load is practically zero. Means if number of stations are less, then the delay is almost zero. Okay, that means if there is very suppose only two devices are connected. Okay, so this is like a point-to-point connection. So that there is a dedicated cable directly connected. So there is no delay. They will be directly transmitting the data. Okay, so basically we will be going with the different frames, how the frames are defined for each of the different standards or different protocols. So 802.3 standard is there. So for 802.3 standard, what is the frame basically? What is the size of the frame? What different components of frame constitute? So we will be looking at that. So here, because we have just seen this Ethernet basically, or the LAN basically works in coordination with the physical layer and the data link layer. So some portion of the physical layer is also used. So that frame that is there. So 82.3 media access control frame size is defined with respect to uh, the content of the physical layer also. So physical layer headers are there. So these physical layer headers are basically constitute of preamble and then SFD. So this SFD is start frame delimiter. So like in the previously that we have already seen, like once we were talking about the framing. So in framing, start and end, or start or flag. Basically, it was having the flags start or end. So that start and end were basically working as a delimiter. Delimiter that will be identifying like as a flag. So here, in case of the frames, this 802.3 frame, it is having preamble. So preamble is a 56-bit of alternating ones and zeros. So this, like if we want to send a frame, so if it is going to a receiver, so receiver should be identifying like what is the start of the when the frame is starting and what the different bits are having the meaning. Okay, so for that there is a preamble. So this preamble is of 7 byte. So 7 byte data that will be of preamble that will be having 56 bits, and all will be alternating 1 and 0. That means the 56 bits will be 101010 up to, like total it will be the 56 bits. So this will be considered as the preamble. So once a frame is coming and it is received by the receiver, so starting 56 bits, if it is 10101010, then this will be considered as the preamble. After that, there should be SFD. So that is start frame delimiter. So SFD value is fixed. So that is 101010, then last 11. So after 56 bits alternating 1 and 0, there will be a flag bit. This will be the part of the physical layer header. Then this will be the part of the data link layer. Okay, so here it will be constituting destination address. Destination address will be given by 6 byte. Source address, that will be given by 6 byte again. So what is the meaning of source and destination? So in case of data link layer, we have seen like, so data link layer basically communicates. Suppose there is a station A, there is a station B. So in between this, there is, you can call it like a switch. Okay. So in data link layer, basically the addressing is done node to node. So node to node addressing is done in data link layer. But in network layer, the addressing is basically done end to end. So that means suppose this is the source and this is the destination. Okay. So if it is source to destination, then for this source, the destination address will be the address of this switch. Suppose this is switch 1, switch 2. Okay. So likewise, uh, once a frame is being transferred from A to S1, okay, then the source address will be the address of physical address of A. Destination address will be the physical address of this S1. So these are the addresses. So these addresses are basically represented in terms of 6 bytes. Okay, it will be addresses will be in terms of 6 bytes. So this 6 bytes, like we already have seen, like addresses in LAN is basically of 6 byte. LAN is there, so its physical address physical address is of 6 byte. Okay, that is written in terms of hexadecimal numbers, two numbers in pair, six pair of hexadecimal numbers basically represent uh, the address of the LAN. Okay, so here, so this is the node to node addressing is done into data link layer. So for that, destination and source addressing is part of the frame. Then length. So this length is basically of 2 byte. So this length is indicating like what should be the length of the frame. Okay, so like framing, we have seen framing. So framing is of two types: variable length and uh, fixed length framing. So if it is fixed length, then the size of the length, this length will be indicating the size of the frame. What should be the size? Or if it is variable length, then it will be like what type of framing is done. Okay, so that will be indicated by this 2 byte data. After that, there is a data. Okay, so there is a data, and along with data, there is a padding. So some padding bits are used. So this actual data into this frame will come here in this part. The actual data will be stored here along with padding. Suppose once we are using the framing, and it is because these LANs are basically going to use the CSMA CD, that is uh, carrier sense multiple access with collision detection. So for collision detection, it is like there is a fixed amount of bits that should be there into the data. So that's why if suppose some data is there that is having a size that is less than the minimum number of data size that is required, then there is a padding is there. Some extra bits are added. So it is the padding bits. And the CRC, that is basically for cyclic redundancy check for error detection and correction. That is of 4 byte. So this is the frame of 802.3 standard basically, or the basic Ethernet. So frame of a basic Ethernet basically. Okay. So yes, we will just go through what is meaning of is. So preamble. So here the preamble is responsible for providing the synchronization between the sending and the receiving device. So preamble is used basically for synchronization. It is a series of 56 bits, 7 byte of alternating ones and zeros found at the beginning of the frame. At beginning of the frame, this will be basically available. Start of the start of frame delimiter. So start of frame delimiter will be given by this value. Just after the preamble, this will be there. Okay, it will be delimiter means it will be just a separator that will be separating uh, the previous frame to the next frame. Okay, or the actual data of the frame. This will be the delimiter. Okay, so as its name implies, it indicates the start of the data frame. Okay, so it will be identifying like what from where at from which location the actual data of the frame is being starting. The start frame delimiter is 1 byte in length. 1 byte in length means 8 bits. Made up of following 8-bit sequence. This is basically fixed. It is fixed. So SFD will be this value that will be a fixed value. Address field. So address field, each of the address field, the destination address and source address can be either 2 byte or 6 byte in length. So if the universal addressing is used, the addressing must be of 6 byte. But if the local addressing is used, then they may be either 2 byte or 6 byte long. So if universal address, so by basically the LAN address, universal address is basically of 6 byte. So if it is universal addressing is used, then 6 byte. Otherwise, it could be of 2 byte also for local addressing. Both destination and source addresses must be of the same length for all devices on a given network. Okay. Length count. So here this is a 2 byte field indicating the length of the data field that follows. So that follows in the sense. So this will be indicating like what will be the length of this data field. Okay, that will be given by the previous length field. It is needed to determine the length of the data field in those cases when a pad field is used. Okay, so whenever we are using the padding, okay, so in that case, what is the length? Because padding is required if there is the smaller length of the data field. If the data is of a small size, then padding is used. So if data is small, in that case, its value will be defined by 2 byte. 2 byte in the sense 16 bit. 16 bit. 16 bit means whatever possible numbers will be there starting with 0 to 2 to the power 16 minus 1. Okay. So between 0 to this number, we can represent by this. So what should be the size of the data? If the data field size is ranging between 0 to 64 k basically, so 2 to the power 60 minus 1, that is 65,000 something, that is 64 k considered basically. So this is the possible size or the length of the data field. It will be indicated by, okay, so accordingly the data field will be given, and if it is less than that, then the padding will be used. So information field contains the actual data packet to be transmitted. Its length is variable. So its length is variable in the sense the length can be varying. So it is not a fixed. Okay. So or varying in the sense sometimes it can be a fixed value, sometimes it can be a different value. Okay. So based on that, there is a requirement of padding. So pad field is used to ensure that the frame meets a minimum length requirement. So the minimum length of a frame is fixed. So that will be decided based on the size of the data, or what should be the size of the data, actual data. The frame must contain a minimum number of bytes in order for stations to detect collision accurately. So because in case of CSMA CD, basically it is given like the tolerance time basically was TFR, frame transmission time. So frame transmission time. So the frame transmission time will be the vulnerable time that we have seen into the CSMA CD basically. So there is a vulnerable time. So that means within this time amount, there is a possibility of collision. So if the propagation delay, or we can say the frame transmission time, is greater than TFR, okay, then we can say like the collision can be detected. So that's why we should be providing a minimum size of the data, or the minimum size of the frame, so that we should be able to detect the collision. So that's why there is a minimum frame required. Next is the CRC that we have talked about. So frame check sequence. So the frame check field is used as an error control mechanism. When the transmitting device assembles a frame, it performs a calculation on the bits in the frame. So that we have already seen like what is CRC codes are there. So different CRC codes, how it will be basically either using the redundancy code, or it will be using the checksum bits. So that is its own work, but it will be using some part of like some algorithm that will be basically useful for error control mechanism. So that is the CRC codes into the frames of 802.3. So here the frame structure of this frame of 802.3 is important. Okay. Yes. One more thing like here, what is the minimum and the maximum length of the frame? So maximum and minimum length of the frame is decided by the minimum and maximum length of the data that can be transmitted. Okay. Through a single frame. So up to like preamble and SFD, these are part of the physical layer system, or these are basically used to basically identify like this is the actual part of the frame. So starting with the destination and destination address, source address, length, data and padding, and then CRC. So this will be basically the actual size of the frame basically. Okay. So here we can count it like 6, 6, 12 to 14, then 4. So 16. So 16 byte is this part, then the data, then comes the data. So here it comes like the minimum frame length is coming out to be 512 bits or 64 byte. That means without data, the total frames are 16. So that means if the total frames are 12, 14, 18, sorry, 18. Okay. So then to make it the minimum 64, the minimum payload length, that means the data plus padding should be minimum 46 byte here. And the maximum payload length that is allowed is 1500 byte. So with respect to that, if we add 46 with 18, that will be coming out to be like 64. So we are going to add 46 with 18. So it is coming out to be 64 byte. So 64 byte is the minimum length of the frame, and the maximum length of the frame will be like it will be with respect to the 18, this 18, this one, and this one. Total is 18. Then 18 plus 1500. So it will be 1500 plus 18. So 1500 18 byte will be the maximum frame length, and 64 byte will be the minimum frame length in case of the 802.3 standard. The same is given here. Yes. So there is an example of Ethernet address. So Ethernet address we have already seen also, like it is of 6 byte. So 6 byte, and it is basically represented by 6 pair of hexadecimal numbers. Means total 12 hexadecimal numbers. So 12 hexadecimal digits, and each hexadecimal digit is represented by 4 bits. So total 12 into 4, that is 48 bits. So one Ethernet address is basically of 6 byte or 12 hexadecimal digits or 48 bits. Yeah, there is a concept of unicost and multicost. So what is the meaning of unicost? So unicost in the sense, so if one is the sender, another one is the receiver. So from sender to receiver, the data is going. So if the data is transferring from sender to receiver, only from sender to receiver to only one station, one station to another station, it will be unicost. Another is multicast in the sense, if a sender is there, but the receivers are more than one. If more than one receivers are there, it will be called like the multicast. So, or it can be considered like, suppose this is the bus structure. If suppose this is going to send, it is going to send. If it is sending on the common bus, it will be received by each other stations. That will be the multicast. So if a transmission is unicast or multicast, that is basically given by its address. It can be identified by there only. So into the address, if the last bit of, or you can say the LSB bit of the address is 0, then it will be called a unicast. If the LSB bit is 1, then it will be called the multicast. It means if it is 0 means if the address is even, then it will be unicast. If the address is odd, or the Ethernet address or the LAN address basically is odd, it will be considered as the multicast. Okay, so either so based on the address also it will be identified. So that's why it is unicast and multicast addresses. So here the least significant bit of the first byte defines the type of address. If the bit is 0, the address is unicast. Otherwise, it is multicast. So the broadcast destination address is a special case of multicast address in which all bits are ones. If all bits are 1, then it will be called like the broadcast. Okay, so broadcast destination address is the case where all the bits will be 1. So that will be the special case of the multicast itself. So broadcast in the sense like in uh, once we are sending a message, okay, so it is going to everywhere. So it will be a broadcast. So in multicast, it will be like it will be sent to or whatever the devices are connected to it. Okay, so it is a special case where if it is a broadcast type, then the address will be all ones. Yes. So here a question is given. So define the type of following destination addresses. So if these are the destination addresses, categorize it into either it is unicast, multicast, or broadcast. So before going to the previous example, we will just look at here. So what happens once we are going to send an address? How the address will be sent is, suppose this is the address is going to be sent out on a line. So if we are going to send an address, the address is sent left to right. Means if this address needs to be sent through a medium, then we should be sending the left side first, then the right side. Okay, so that means we will be starting with the left side first. So if we are sending the left side first means this 47 byte, this 47 as a single byte. So this will be considered as the byte 1. This will be the byte 2. Similarly, this is the byte 6 that will be sent. So once we are sending the address, the byte that we are sending, it will be sent left to right. But within this byte, so this is 47. So 4 is represented by 0, 1, 0, 0, and 7 is represented by 0, 1, 1, 1. So within this byte, we will be sending from right side to left side. So within this byte, right to left, but within this address, within the complete address, the left byte will be sent first to the line. So how it will be sent is like here it is given. So address is sent left to right, byte by byte. So byte by byte, left to right, we will be sending. So we will be going left to right, but for each byte, but it is sent right to left bit by bit. So bit by bit that we will be sending, it will be this like how. So once we will be sending, so we will be sending 47. So 47 we will not be sending likewise. So 47 will be opposite to that. So it will be this one will be sent first, then this one, next one will be sent, the next one will be sent, then 000, so 30 will be sent, then 1 and then 0 will be sent. So this is how it will be sent. So if we want to find out here, so either it is what type of address it is, either unicast, multicast or broadcast. So we need to see this one. So this is 4. So this is, or we can consider like this 4A. Okay, so into it is 4A is given. So if it is 4A, that means we need to find out like what is the LSB basically. Yeah, so if it is 4A, so 4A, so here, so 4 will be like 0, 1, 0, 0. A will be here. So A is 10. So 1, 0, 1, 0. Okay, so this is the case. So here if it is uh, A, A is 1010. So this 0 will be indicating the unicast. Okay, so similarly, this is 47. So into this 47, we need to write it down 01004 and then 7 is there. So 7 is 0111. So if it is 111, so this will be indicating the multicast. This is unicast. So this is even, this is odd. So we need to basically focus on this part. So into the left most byte, then right side. So into this byte, what's the right side digit? The odd or even. Okay. So based on that, and if all the addresses or all bits are 1, then it will be called like the broadcast address type. Yeah. So here it was 47. So this is the byte 1. So into that byte 1, this will be used for, this is odd. So it is multicast. This is how it is basically identified. Yes. So the next one is like what different types of Ethernet. So standard Ethernet having common implementations. So how it is. So basic Ethernet that is there. The standard Ethernet it is of having 10 Mbps. So it's different types of this is there. How different implementations are there. How it is implemented. So it is 10 base 5. Its meaning is 10 is 10 Mbps. Base is base band. So this indicates the base band. And 5 indicates 500 meters. So it will be working for 500 meter, sending a data for 500 meter with 10 Mbps, transmitting a baseband signal. Okay, so and it uses bus topology, and in case of cable, it uses thick coaxial cables. Similarly, 10 base 2, that means it is useful for up to 200 meters. So it will be using the bus, and it uses thin coaxial cable. Next one is 10 base T. So T is basically the one that will be using the uh, star topology, and it will be connect using the cable that is UTP type of connectors. We have already seen what UTP type of connectors. Okay, so 10 base F that will be using the optical fibers basically. Okay, so this is coaxial cable. This T stands for twisted pair. So okay, so UTP we have already seen the type of twisted pair. So These two will be using the star topology, and these two will be using the bus topology. So these are the different implementations of the basic standard Ethernet. Okay. And what type of encoding is done? So here the Manchester encoding is done. So Manchester encoding is done at the sender side, and at the receiver side, the decoding will be done as the Manchester decoding will be done. So the same thing is explained here. So how it is basically implemented. So 10 base 5, 10 Mbps baseband and 500 meter. So this is how it will be available. So coaxial, this is thick coaxial cable, maximum of 500 meter length should be there. So there will be suppose this is the server and these are the clients. So in between the distance will be like 500 meter maximum. So this is 2, that is up to 200 meters. So it is 185 meters. So this is how it will be implemented. It is given. Okay. So yeah, twisted pair and then optical fiber. Then changes in the standard. So instead of using only the standard Ethernet that is of 10 Mbps, different higher speed Ethernets have been implemented. So these higher speed Ethernets are basically considered as the next Ethernets, okay, or evolution of the basic Ethernet to the next fast Ethernets, okay. So 10 Mbps standard Ethernet has gone through several changes before moving to the higher data rates. So to increase the higher data rate, different changes have been done. So these changes actually open the road to the evolution of Ethernet to become compatible with other high data rate LANs. Okay, so Ethernet is having higher data rate that can be considered different data LAN that with higher data rate basically. Okay, and here bridged, switched, and duplex Ethernet. So how it is basically configured, that is given. And here a sharing of bandwidth is given, means like if it is first session, for some time it will be sending for this time. The remaining time will be shared by the second station. So how the sharing of the bandwidth is basically done, that is given. Yeah. So bridge type of Ethernet. So without a bridging and with the bridging. So if we are using the bridge, so some devices will be connected. Along with that, connection will be done with respect to the bridge. There will be some disadvantage and some advantage by using the bridge. So once we are using the bridge, it will basically configuring the systems very accurately and without uh, errors that can be done. In the switched Ethernet, there is a common switch. With that, there will be different devices will be connected, stations will be connected. Full duplex switch. In that, devices are connected or the stations are connected such that there is full duplex, means it can transmit and receive at the same time. This is the basic difference. Yeah. So different Ethernets modification to or evolution to basic standard Ethernet. So one is the fast Ethernet. So this fast Ethernet is called 802.3U. Another one. Okay. So instead of a 10 Mbps, it was having the 10 times, that is 100 Mbps speed. Okay. So the fast Ethernet topology is point to point. It can be having a point to point connection or it can be configured in star topology. And this fast Ethernet, its basic implementations are there. So it is 100 base TX. So this TX is 2 wire. Okay. So 2 wire category with 5 with category 5 UTP. So twisted pair. So we have already seen this UTP. So here 100 Mbps base TX, 2 wires will be there and it will be using twisted pair. T stands for twisted pair, X pair 2. Okay. So 100 Mbps speed will be there. So different implementations of the fast Ethernet. So it is 100 Mbps with base FX, means 2 wires with optical fiber. 100 Mbps base, then T4. That means 4 wires with category 3 UTP. So different categories of UTPs are there. We have already gone through it. So these are the different devices that are basically used in fast Ethernet. Okay, how we can implement it. So here for encoding and decoding. So this is the block coding. We have already seen 4 to 5, 4B to 5B coding is there. Then MLT. MLT encode, MLT3 encoder are used here basically. So this is how the encoding is done. So in fast Ethernet, the MLT3 type of encoding is basically used. So yeah, the summary is given here. Another one is gigabit Ethernet. So this gigabit Ethernet is also called like 802.3 Z. Okay, so it is having 100 Mbps of speed. Sorry, 1000 Mbps speed. Okay, so gigabit, that means 1 Gbps speed will be there. That is gigabit Ethernet. So in full duplex mode of gigabit Ethernet, there is no collision. The maximum length of the cable is determined by the signal attenuation in the cable. So this is like there is no collision into the full duplex type of gigabit. So what are the different topologies? It is configured in point to point, or it can be used in star topology. It can be having two star topologies, or it can be having a hierarchy of star topologies for gigabit Ethernet. Similar to the implementations, so here gigabit Ethernet is implemented likewise. So how it is having 1000 base SX. So two wires, short wave fibers will be used. LX, long wave fibers will be used. X for two wires. 1000 bit CX, so two wires. C, that is for copper STP. Okay, so shielded twisted pair. Okay, so that we have already seen. And then 1000 base T, that is basically the normal unshielded twisted pair. Four wires will be used. So for here, NRZ line encoders are used. Okay, and this is block coding. So block coding will be used, and NRZ line coding will be used. And while decoding, 4D PEM encoders are basically used. So this is how the encoding is done into the gigabyte. Yeah. So here in token bus. So one thing. So in case of token bus, it is considered 802.4. So in token bus standard, it basically specifies token bus media access control method. So what is the token bus media access control? So it is one of the two token passing access methods. So token passing access method in the sense like in token bus, the devices will be connected in the bus topology. So into this bus topology, the devices will be connected. So here uh, it will be physically connected in bus. So in IEEE 802.4 is based on physical bus or tree topology. It will be having a physical bus or tree topology. The token bus approach requires a station to have possession of a token in order to transmit. The token is passed from station to station in a logical ring. So its meaning is like this is the different devices connected in physical form, that is in bus mode. And in token, use of token is like to avoid, there is a basic rule to avoid the collision. So for that, if suppose each station 1, 2, 3, 4 and 5 is there. If all are having data and they want to send, they will be sending, then there will be a collision. So that's why there is a concept of token. That means there is a frame that will be passed to anyone. Suppose if this it is passed to the station 1, it is having token is possessed by station 1, then station 1 can only transmit the data, otherwise others will be staying idle, they will be in receiving mode. Okay, so if they are sending, if a particular station wants to send the data, it has to have the token. So token passing means if 4 wants to send the data, it will be receiving the token. Once it has received the token, it will be sending its data. Once its data is completed, then it will be sending the token, and it will be passed to the next station that wants to send the data if they are having the data. So here there is called like in token bus, there is a virtual ring. Virtual ring in a sense, in physical form they are connected with bus topology, but virtually they are connected in the ring topology, so that this virtually ring is basically for the token passing. If suppose 4 has done the uh, data transfer, then it will passing the token, and token will be going with physical medium, but it will be received by the next either 5 or by 3. Or likewise, if 3 has done the communication or sending the data, then it can pass the token to 2 or 4, likewise, and in any direction it can go. So it is having the token is passed from station to station in logical ring manner. It will be using the logical ring. Okay. So it uses highly reliable cable television equipment. It is used in highly reliable cable television equipments. It is more deterministic than 802.3, although repeated loss of token at critical times can introduce the uncertainty. If suppose the token is lost, then can be because if token is lost, suppose 4 is transmitting and the token is lost at 4, then others will keep on waiting for the token only, because once they are having the token, then only they can send the data. Can easily handle shorter frames, so no limitation on the frame size. So here there is no limitation. Once it is having the token, it can send the data, whatever amount of data they want to send. But in the basic Ethernet, there was a size. There is one frame should be having what amount of size that is fixed. But here there is no size. Once you are sending data, you should be having a token. If you are having token, send whatever data amount you want, send it. After sending, you can release the token, so that can be accepted by some other station. So no limit on the frame size. It supports priorities and hence suitable for real-time traffic. So it uses some priorities also. So that can be used for real-time traffic. It also has excellent throughput and efficiency at high load. So even if high loads are there, then also it is having the higher efficiency and throughput. So how it is given the priorities? So priorities are given based on the number of the stations. So if suppose the stations are numbered likewise, so if number 5 is there, so 5 will be given higher priority, then 4, then 3, 2, 1. That means even if the 20 devices are there or 20 stations are there, they will be getting their chance after each of the stations have sent their data. So they have some priorities also, and they have excellent throughput and efficiency at high load also. If high load is also there, then also each device will be getting a chance to send the data. So here the frames in case of token bus transmission is given by like here. So there will be a preamble of 1 byte. Then start of frame will be 1 byte. Then frame control, there is a frame control of 1 byte. The destination address that can be of 2 to 6 byte. Okay. So if it is standard form or universal address is used, so it will be 6 byte. Otherwise 2 byte can be there. Source address, then data. So here data can be ranging between 0 to 8182 byte. Okay, and then frame checksum, that is a 4 byte, and there will be an end of frame, that is 1. So here there was a start of frame and end of frame of 1 byte. So this is the format of the token bus or IEEE 802.4 frame formats. So this is the meaning of the same thing. What is the meaning of the start of the frame and then frame control that we have already seen? So start of the frame is nothing but the start delimiter. So it will be identifying like this is the location. After that, the frame actual data of the frame is starting. Okay, so that will be the start of the frame. So up to here, this will be the actual data of the frame. Yeah, the next one is the token ring. Okay, so token ring is also called like IEEE 802.5. So IEEE 802.5 is the second of the token passing access control method. Okay, so token ring is most commonly used in a network structure following both a logical and physical ring topologies. Okay, so the right to transmit is controlled by a token. So okay, so here the right to control will be right to transmit is basically controlled by a token. So it uses a point-to-point connection, and hence the engineering is easy in this case. and any transmission media can be used. Transmission media in the sense, what type of transmission media, what type of cables can we can use. Okay, so any type of transmission media can be used. The use of wires centers make the token ring the only LAN that can detect and eliminate cable failure automatically. So here the use of wire centers. So in ring topologies, basically it's like can detect and eliminate the cable failure by itself. Okay. So like 802.4 prioritize also possible. So priorities are possible here, although the scheme is not a fair in the sense it may be like higher priorities will be given to uh, or each of the system will not be each of the stations will not be getting their fair amount of time, and very short and very large frame both are possible, so it can support both large and small frame size. At very high load, the throughput and efficiency are excellent. That means even in this case also, if the load is higher, then also it can be working very efficiently. Okay. So in that case, basically it is star. So in star means, sorry, in a ring, basically there will be different uh, stations will be there. So here also the token passing is used. So token passing as used into the token bus. So here there will be a token. So token will be passed likewise. So in those who are having the token, they will be able to send the data. They will be controlling the send of data. Okay. And also here there is a monitor station is there. So there is a monitor station that is basically used to monitor where the token is right now, basically. Okay. So and here it is considered to be unidirectional. It is considered to be unidirectional. So unidirectional means it will be either in clockwise or anti-clockwise. So this is the token. So token will be used to send the data here also. So the difference is it will be using the ring topology, and the previous one was using the bus topology. Okay. So token passing will be done to both, and here the data rate is basically the 4 Mbps or 16 Mbps. And encoding. So here the encoding that will be done is the same differential Manchester. So it will be using differential Manchester encoding. Differential Manchester encoding will be used. And also here the variable size of frame will be there because it is using the token. Once a particular station is having token, it will be able to send whatever amount of data they are having. There is no limit on the size. Okay. Yeah, here the frame. What is the frame? So here also the frames are given. So start of the frame, then access control. So there is an access control, then flow control, source address, destination address, then data. That will be no limit. Okay. Then frame checksum, that for errors, frame status, and end of the frame. So start of the frame, end of the frame, that will be delimiter basically. Then there comes access control and flow control. So here access control, this will identifies whether the frame is a data frame or a token. So it will be basically identifying that. It contains a bit used to identify a constantly busy token, a priority bit, and reservation bit. So it will be checking for any priority bit or any reservation bit. So there is a reservation and priority, both are used. So a reservation in the sense there is a frame. In that, in the frame there is a, if suppose 10 stations are there, so 10 bits are, each station is having a priority reservation bit. So each station will be having one bit. Okay. So if they want to have a reservation, they will be turning that bit 1. So that is basically the reservation bit. So this access control field is basically identifying like which station is having the data, or which station wants to send the data, or which one station is having the right to send the data. Next is frame control field. So this field identifies the frame type, or and for certain types of frame control, the function is to perform. Okay, so it is like basically frame control that will be basically identifying like what is the frame type. Okay, and for certain type of control frames, what is the function it is going to perform. So either what is the frame type and what type of function it is going to perform, that will be identified by the frame control field. Address field and information field, we already know. Checksum, we already know. Ending delimiter, the same thing. Frame status field. The frame status field contains the address recognized and frame copied control bits. So it will be frame status field. It will be basically identifying the copied, whatever the frames it has copied. So by identifying the status of the particular field, it will be identifying what is the status of that particular station basically. Okay, so based on its address and the frame fields basically. So these are the basics of token bus and token ring.